Hello, I'm David Lobb at the University of Manitoba, and I work in soil and water conservation. And I'm one of the leaders of the group dealing with on-farm nutrient capture and recycling as part of the AquaHacking Challenge.
My name is Maren McRae, and I'm a professor at the University of Waterloo.
And my name is Maggie Rummold, and I'm the Executive Director of the Canadian Water Resources Association.
The big water issue we'd like to tackle is the eutrophication of Lake Winnipeg. It's the largest of the lakes in Western Canada. As a consequence of the increasing eutrophication, algae blooms are increasing in frequency and extent over the past few decades. These algae blooms pose a significant ecological threat to the lake and an economic threat to those whose livelihood is derived from the lake. In 2013, Lake Winnipeg earned the title as the most threatened lake in the world by the Global Nature Fund. Now this, although it is a very significant issue in Western Canada, it is not unique to Western Canada. Lake Erie is also another freshwater lake that has the same situation. Now Lake Winnipeg, by the numbers, there's about $20 million a year inland fishery that takes place on the lake and a multi-million-dollar recreational industry around the lakes, particularly in Grand Beach. And there's a multi-million-dollar hydroelectric industry. And the basin or the watershed, by the numbers, it's the second largest watershed in Canada. It is 1,000 or 1,000,000 square kilometers. And it's a semi-arid to subhumid climate, which becomes a significant factor in the water quality issues that we face. The runoff is dominated by snowmelt, and it's a relatively level landscape across the prairies. And it's home to 6.6 million people. Over 50% of the of the land is agricultural land, and about $20 billion per year is generated by the agricultural industry, and over $2 billion a year in crop production alone in Manitoba.
So where are the sources of phosphorus that are entering Lake Winnipeg? Well, the phosphorus comes from many sources across the basin. The majority enters through the Red and Assiniboine River, so about 73% in 2001. And of that portion, almost half, 30%, comes from Manitoba and Saskatchewan. And of that portion, roughly 2/3 comes from the rural landscape, so cropland, pastures, farmyards, and all of the other land uses. So there is potential to reduce phosphorus loading to Lake Winnipeg from all sources. So this slide shows the same sources over time and the contributions of both flow and phosphorus. So if you look at the graphs on the left side of the screen, we see that most of the flow into the lake comes from the Winnipeg and Saskatchewan rivers, and very little comes from the Red River. But when we look at the phosphorus contributions, most of the phosphorus is coming from the Red River. And if we look at the graphs on the right-hand side of the screen, the majority of this happens during the snowmelt period, about 80%, which happens over about a 2 to 4 week period between March and April in any given year. So simply due to its prevalence in the basin, agricultural land is a major contributor to runoff, leading to nutrient losses, which of course lead to eutrophication and algal blooms. So the problem is that we have to maintain efficient and profitable crop production to ensure food security for local and national markets. But we have to do this while we minimize the contribution of farming practices to nutrient runoff from agricultural land and the loading to surface waterways and ultimately to Lake Winnipeg. So the challenge in this landscape is that even though it's a relatively dry climate in the prairies, excess moisture is a major threat to maintaining efficient and profitable crop production. So excess soil moisture and water standing on the fields from local spring snowmelt and rainfall represents the majority of crop insurance claims in Manitoba, and those claims continue to rise, as you can see from the graph on the bottom left of the screen. So ultimately, farmers must drain their land. The challenge is finding a means of draining agricultural land while reducing the load of nutrients in that drainage water. So there are, So there are some opportunities. To keep nutrients, we either have to keep them on the fields and prevent losses, or we have to capture them and trap them somehow after they exit the fields and reuse them. Most of the beneficial management practices, or BMPs, that we've tried to employ to prevent losses from fields, a lot of them don't work very well in this climate type, and this makes keeping nutrients on the fields challenging. So capture and reuse is another option. But this system has to work in this very level landscape on which most of the runoff happens during frozen and thawing conditions, which of course poses its own sets of challenges. To improve water quality, we either have to keep nutrients on the fields and prevent losses, or capture nutrients and trap them and reuse them after they exit fields. Most of the BMPs that have been developed to keep nutrients on fields haven't worked as effectively in this landscape because of the hydrology and the landscape in general, and the associated challenges. So capture and reuse is that as another option. But again, these approaches have to work in this very level landscape in which most of the runoff happens on frozen or partially frozen conditions, which poses its own set of challenges. So again, one approach to reduce agriculture's contribution to nutrient delivery to the lake is to capture and reuse the nutrients before they're lost from the agricultural landscape. And this can be on the field, at the edge of the field, or downstream from the field. And it can be done at the field scale, farm scale, or the subwatershed scale. So there are a few practices that have been developed to achieve this form of nutrient recycling, and there are most certainly other practices that could be developed if a few bright minds come together to tackle this challenge. Water management within the watershed, particularly at the farm scale, is key to reducing the delivery of phosphorus to Lake Winnipeg from agricultural sources. The capture and the reuse of phosphorus that leaves the farms has the potential to substantially improve water quality in Lake Winnipeg and throughout the watershed in general. We've pulled together some resources. Some examples of the resources that we've gathered are shown on this slide, and we will also provide an additional list of resources that will help point people in the right direction towards coming up with some innovative solutions that we're excited to hear.
So we hope that you're excited about our challenge, the on-farm nutrient capture and recycling, and we're looking forward to answering any questions you might have. There is a join us. We hope you can join us on the Ask Me Anything session on March 9th. And apart from that, feel free to email us, get in touch with us, ask us some particulars before you decide. We're open to your questions. Looking forward to working with you, and hopefully we'll talk to you soon. Thanks.